Good morning, good afternoon, and good evening to everyone of us here. My name is Innocent Bukenya. Again, I'm back here to take you through item number 1. We made our first tutorial and we looked at our expectations as far as item number 1 is concerned, the format of the paper, and what exactly we are to meet, what exactly we are going to meet when we are doing this item. Now for today, like I told you yesterday, the theme for this item is only numbers. And the topics, like you can see here, we have number bases, we have working with integers, we have fractions, percentages and decimals, we have ratios and proportions, and lastly, numerical concepts 1 and 2. Now, I will not take much time, but at least I would like to take us through exactly what we expect in these areas. I told you yesterday, we may not have all these topics appearing in an item, but at least 3 topics are expected to appear. If I told it is a standard item number 1. Like we looked at UNEB last year, that was 2024, we looked at parts of these items, parts of this theme that came in that item. So if you can look at today, I have tried to note down some expectations as far as number bases is concerned. In fact, after this, we are going to have a sample of these items and we'll be finding out, we'll be noticing out that some parts have been set, others have been left out. But I told you, the highest chances, or the chances known to miss topics like number bases, working with integers, fractions, percentages, and decimals, ratios, and proportions are very, very high. You may not miss those parts. However, I'm not saying that numerical concepts will not be there. It is also part of item number 1. But most of the times, you cannot miss working with integers, fractions, percentages, and decimals, ratios and proportions, and number bases. Now, what do we expect in number bases? In number bases, what is normally set here is converting bases. And in this category of converting bases, if you can look at number Roman 1 here, we have what you call converting from any base to another base. For example, from base 3 to base 5. Or we can convert from base 10 to any other base. And or we may convert from any other base to base 10. It depends on what the question wants. Now, students are getting these challenges. A question comes, for example, we are going to look at these applications in the sample of items that we are about to see. We shall be seeing how the number bases are appearing in these scenarios. But to have told you, most of the part that is normally assessed in the bases, most times is converting from a base to another base, from either base 10 to another base, or any other base to base 10. Now, a question comes where we're required to convert from base 3 to base 5. And someone wants to make a direct conversion. There's no direct conversion of base 3 to base 5. But what we do is this. We first convert any given base to base 10. Then after converting that given base to base 10, then you can convert to any other base. For example, if you are converting from base 3 to base 5, we first convert base 3 to base 10. Then after, from base 10, we convert to base 5. And when you're converting base 10 to any other base, we use the ladder method, where you have the number where we have actually the base we are converting to, the number, and the remainder. Hope those things you know, because I may not take you through those steps, but at least I find most of the learners getting confused with this. So when you're converting from base 10 to any other base, that's when you use the ladder method. Those three columns where you have the base you're converting to, the number you're converting, and the remainder. So that is when you're converting to base 10 to another base. But when you're converting from another base to base 10, that's when you use the expansion thing. You expand the base. Where, for example, you have 2, 1, 2 base 3, so it is 2 times 3 plus, like that, you know, those converting, where you power the bases from the right-hand side, beginning from the 0. So, that is converting from any other base to base 10. But we find learners getting confused with these two things. A learner, some of you don't know when to convert from a base. I mean, when to use the ladder method, when to expand. But I think now you can get that. Another fact to note is the names of the bases. Nowadays, people get confusing people with the names of the bases. You find examinations where they are not saying directly base 2. But if you can see, here the number system, base 2, that is the binary base. Have base 3 called the trinary base, base 4 quaternary base, base 5 quinary base, base 6 sexagemal base, base 7 septimal base, base 8 octal base, base 9 nonary base, and base 10 decimal base. So those are the names of the bases. You also expect such names to appear. They may say that someone wants to withdraw the money, but the pin is 256. The pin is written as 256 in octal base, and you need to convert this to base 10 to get the actual pin. So nowadays they are bringing in names. So we are looking for all the areas where we must trap this item number 1. Like I told you yesterday, item number 1 is a must pass. Because it's very cheap, very simple, and we can all get it right, all the marks. Okay, I think I've talked something about bases. Just know that you're going to be converting a base, and you get the names of the bases. And by the way, any other thing can be set on bases, because I'm not limiting you. That's only the thing that is set on bases. No, but as I'm saying, that is what is common with bases as far as item number 1 is concerned. What we expect in working with integers? I'm just giving you the best expectations, or what may not miss with working with integers. Number 1, we have written like writing numbers from either figures to words or words to figures. That one is so common. And there is no identification mark whenever a student converts. They have given a figure, the figure is written a number is written in words. So just writing it in figures, you earn yourself a mark. So expect such as far as working with integers is concerned. Number 2, what we expect is application of LCM and HCF. Here, I will urge you, please, go and find out how we get the LCM. Maybe I can just talk about something very small about the LCM. If you're using the ladder method, you find any factor, beginning from the smallest factor, and normally test with the 2. If I don't have any figure that can be divisible by 2 and you get no remainder. So if you find any one figure, please deal with that one. But for HCF, it's not the case. The factor you get must be a factor of all the figures available for the HCF. Get that difference. I may not go through that. I know people, as per now, people can approach that. But I'm going to talk about when do we apply LCM. Because again, students are facing that challenge now. They don't know when to apply the LCM, when to apply the HCF. LCM is the lowest common multiple, and HCF is the highest common factor, which we call the greatest common factor. So some of you don't know when to apply the 2. But let me talk about the LCM. We apply the LCM when I'm talking about, I normally call it 2 parties meeting together, There can be two events. They can be, for example, let me give you direct examples. They can say that at a certain school, a bell for O level for changing lessons goes every after 30 minutes, and for A level goes after every 40 minutes. If both bells were rung together in the morning at 8 a.m., at what time would both bells be rung together again? So that is LCM. Another one can come that in an hospital, a doctor checks on the patient every after 2 hours, whereas a nurse checks on the patient every after 3 hours. After how many hours will the doctor and the nurse all together check on the patient? Again, that is an application of the LCM. You see something like two parties want to come together. Two parties are meeting at the same time. They can still bring traffic lights at Wandegeya, show red every after 3 hours. Or traffic lights at Mulago, show red every after 4 hours. After how many hours will the two stations of traffic lights show red? So that is application. It is another one that a student has two parents. One parent visits him every after 3 terms. The other visits him every after 4 terms. After how many times will both parents visit the student altogether? So that is an application of the LCM. Now issues, whenever you find like any figures, but when the parties are not meeting, there is no anywhere we are seeing the parties coming together. So that is not the LCM. That is the highest common factor for those parties not come together. But we find out that let's say an organization is giving out